You've seen how to add and subtract rational numbers. In this video, we extend into multiplying rational numbers. Let's start with an example. There are 5 oil derricks drilling holes that are each 35.3 feet below the ground. What is the total distance drilled? Express the result as a negative rational number. Each hole drilled can be modeled by the rational number negative 35.3. 5 such holes can be modeled by this addition statement. But this is an example of repeated addition, which can be modeled by a multiplication statement as shown here. 5 times negative 35.3, which is equal to negative 176.5. The product is negative because one of the factors is negative. The product of a positive integer and a negative rational number is a negative rational number. Let's look at another example. A debit of $35.75 needs to be turned into a credit for the same amount. Show an integer multiplication statement that results in this credit. A debit of $35.75 can be modeled by the negative rational number negative 35.75. The goal is to turn this rational number into its opposite, 35.75. To turn a rational number into its opposite, multiply by negative 1. In this case, multiply negative 35.75 by negative 1. Multiplying a negative by a negative makes it positive. So this equation shows how to convert a $35.75 debit into a $35.75 credit. Let's look at another example. A debit of $75.25 was mistakenly added to an account and needs to be turned into a 20-fold credit. Show a multiplication statement that results in this credit. A debit of $75.25 can be modeled by the rational number negative 75.25. The goal is to turn this number into its opposite times 20. We know that to turn a debit, which is negative, into a credit, which is positive, multiply by a negative number. And not just any negative. We need to increase the absolute value of the original value 20-fold, which means multiplying by a factor of 20. So we take negative 75.25 and multiply by negative 20, as shown here. The result is positive 1505. Let's look at a final example. Take two rational numbers a and b. Show that the product of the two numbers is itself a rational number. Use the definition of a rational number in your proof. Using the definition of a rational number, we can write a as the ratio of integers a and b, where b is not 0. Similarly, for b, we write the rational number as the ratio of two integers c and d, where d is not 0. Multiply these two ratios. We get a times c in the numerator and b times d in the denominator. So we have a product of integers here and the product of integers here. The product of any two integers is itself an integer. So we can rewrite the numerator and denominator as two new integers, e and f. E is the product of a and c, and f is the product of b and d. We now have the ratio of two integers, e and f. Furthermore, since b and d are non-zero, that means that f is non-zero. So a times b is the ratio of integers e and f, where f is not 0. This is the very definition of a rational number. So we conclude that the product of two rational numbers, a and b, is another rational number.